In this video, I'm going to introduce the tricks or mathematical strategies you need in order to solve limits in your Calculus 1 course. So the first major strategy we can use to solve limits is by factoring. So for instance, I have an example here. I have the limit as x goes to 2 of x squared plus x minus 6 over x minus 2. And we can't just plug 2 in to this limit because then we'll end up with 2 minus 2 on the bottom, which would just equal 0, and we can't divide by 0. So in order to get around this, we can factor and hope that something cancels. So let's factor this. And factoring is a very important skill, so I'd highly recommend that if you are kind of rusty on your factoring, you do lots of practice with these limits, like an insane amount of practice. Do every question in the textbook you're using if you're rusty on your algebra skills. So x squared plus x minus 6. How do we factor this? Well, if we have x squared plus x minus 6, we need the last two numbers to multiply to -6, and then when we add them together, they have to add up to 1 to get the positive x. So if we factor this, it will just be x plus 3 and x minus 2. Of course, again, we can just multiply these out to make sure that they are the same. We'd have x squared plus 3x minus 2x minus 6, which would simplify to x squared plus 6 minus, or x squared plus x minus 6. Then on the bottom, we still have x minus 2. And at this point, we have some luck here because these can cancel. And then we'll be left with the limit as x goes to 2 of x plus 3. And at this point, we can just substitute x in. So now we can just say it's 2 plus 3, which is equal to 5. Now, of course, these curves aren't the same. So x squared plus x minus 6 over x minus 2 is not the same curve as x plus 3. And this is important to note. However, the limits are preserved. So if we graph this, we can see that the limit as x goes towards 2 of x squared plus x minus 6 over x minus 2 will tend to 5. However, when we do this canceling, we are changing the function. That is just a very important thing to note. So the limits for these are the same, but the functions are not. The graphs are completely different. So that's factoring. Another method, like factoring, is just to expand terms. So here we have x minus 4 all squared minus 16 over x, and we want the limit as x goes to 0. In this case, we can't just plug x equals 0 in because then we're dividing by 0 again. So we'll have to do some expanding. So if we expand x minus 4 squared, then maybe we'll be able to find something to cancel. We can get rid of that x on the bottom somehow. So the top will be x squared minus 4x minus 4x, so it'll be minus 8x. And then negative 4 times negative 4 is positive 16. So we have all that. After we expand it out, then we subtract 16, and then we divide by x. Okay, this looks like maybe something we can work with, so let's simplify as much as we can. The limit as x goes to 0 of, well, this will be x squared minus 8x, and the plus 16 and minus 16 cancel each other out, so that's good. Then we have x on the bottom. Oh, what do we have here? Well, now we can cancel an x from the top and bottom, so we can divide the top and bottom by x, and we'll be left with, so essentially, cancel these out, we'll then be left with the limit as x goes to 0 of x minus 8 over 1, which just simplifies to x minus 8, and then if we plug 0 in for x, we'll have 0 minus 8, which is just equal to negative 8. So by expanding terms, we were able to cancel out that x on the bottom and find the limit. Again, I have to really emphasize that, of course, x minus 8 is not the same diagram as x minus 4 squared minus 16 over x. They're different graphs, they're different functions, but their limits happen to be the same. So that's expanding terms. The most complicated trick that everyone is confused by in their introduction calculus course, because they never really practiced this in high school, is rationalizing numerators or denominators using the conjugate. So here we have y goes to 0. There's nothing to expand, there's nothing to factor, but I have to get rid of this y squared on the bottom in order to plug in a limit. So what do? Well, essentially, I want to multiply the whole thing by 1. Now, just multiplying by 1 on its own isn't very helpful. But if we multiply by 1, where we use the conjugate of a term we already have, then maybe things will look nicer. So what is a conjugate? Well, if we have some a plus b, then the conjugate is just a minus b. So what happens when we take x minus a and we multiply by the conjugate x plus a? What nice thing happens here? Well, we end up with x squared minus ax plus ax plus a squared, which just gives us x squared. This should be minus a squared, so it should be x squared minus a squared. So that's nice. So if we take a look at our square root of y squared plus 4 minus 2 over y squared, this term here is a square root. But if I multiply by the conjugate, then I'll be able to square it. And if I can square it, that means that I can cancel out that y squared on the bottom. So let's do this. Let's multiply by the conjugate. Now, how do we form the conjugate? Well, we take two terms, we'll call them a and b, and this would be a minus b in this case. So we just multiply by a plus b. So that'd be the square root of y squared plus 4, and then we add 2 instead of subtracting 2. So that's the conjugate. And of course, we have to multiply the whole thing by 1, so that's where this trick comes in. We just multiply the top and bottom by the same thing, and this is just the same as multiplying by 1. Okay, so now that we've multiplied by 1 with a really fancy method, we can then multiply these out and maybe get a nicer limit. So I said before that if we take x minus a times x plus a, we'll get x squared minus a squared. So we don't really need to take all the terms on top, because we know that if this is our x and we multiply them together, we're going to get x squared. So on the top, we're going to end up with y squared plus 4. And if this is minus a and this is plus a, we're going to get minus a squared. So what is a? A is 2. What is a squared? Well, 2 squared is 4. And we're going to end up with minus 4 because we're going to end up with minus a squared. So now we have y squared plus 4 minus 4 on the top. And then on the bottom, well, we just multiply them together. So we're going to have y squared on its own. And this will be multiplied by the square root of y squared plus 4 plus 2. Now this ugly thing is still going to be on the bottom. We're just going to hope that it doesn't cause a problem for us. And of course, I really should be consistent and say that, right, this is, in fact, the limit as y goes to 0 of y squared plus 4 minus 4 over y squared times the square root of y squared plus 4 plus 2. So we can simplify a little bit. On the top, the plus 4 and minus 4 will cancel out, and we'll just be left with y squared. Now at this point, we can cancel out these y squareds, and what are we left with? Well, we're left with the limit as y goes to 0 of 1 over the square root of y squared plus 4 plus 2. Now this is nicer because we can plug in y equals 0 now. Because if we do, we're not going to get 0 in the denominator anymore. So if we plug in 0, this is just 1 over the square root of 0 plus 4 plus 2, which is just 1 over the square root of 4 plus 2, and of course the square root of 4 is just 2. So this is 1 over 2 plus 2, which is just 1 over 4. So the limit of this nasty thing is just 1/4. And by using the conjugate, essentially multiplying by 1, we're able to turn it into a form that we can reduce and then get a value out of. Of course, with a graph, we could see very clearly that the limit was 1/4. But just looking at it algebraically, it's very hard to tell. So using these mathematical tricks and methods, we can get something we can work with. Okay, so those are 3 really important tricks. In fact, they're not even tricks, they're methods. So let's do an exercise or two and practice some more. So here I have the limit as t goes to 0 of 1 over t minus 1 over t squared plus t. Of course, we can't just plug in 0 because then we're left with 1 over 0 in both cases. So here's another trick you might have forgotten, which isn't even a trick. I shouldn't call them tricks because these are just methods. They're not tricks. They are methods that you should know. Well, let's factor some things first and see if we can find a common denominator. So this would be the limit as t goes to 0 of, well, 1 over t we can't really do much with, but we can subtract 1 over and we can pull out a t. This will be t times t plus 1. Okay, so we can find a common denominator, and our common denominator will be t times t plus 1. So we should just multiply this 1 over t by t plus 1, and then we can put them together. So again, more just subtraction and addition with fractions. Again, you should probably review this if you don't quite remember. But just to show the steps here, so the limit as t goes to 0, we need a common denominator. So we can multiply by t times t plus 1. In fact, we can just multiply everything by the common denominator. So we can say this is 1 times t plus 1, and this will be all over t times, I guess that'll be times t. And then we subtract, well, we multiply that, t times t plus 1, and then we'll end up with, well, it'll cancel, so we just minus 1 on top. In fact, maybe I should just simplify this right away. So essentially we'll end up with t plus 1 over t times t plus 1, which is the common denominator, and then we subtract the 1 originally. So essentially we just multiply by whatever's not common. So we have t already, so we just take the t plus 1, we multiply by the 1. We already have t and t plus 1 on the right side, so we just keep the 1 there. Okay, and now we can simplify a little bit. So this is the limit as t goes to 0 of, well, t plus 1 minus 1 is just t, and this is all over t times t plus 1, and I see something really nice here. I see that I can cancel these t's out. So now we have the limit as t goes to 0 of 1 over t plus 1. We can now just plug in 0 for t, and we'll get that this is just 1 over 1, which is just equal to 1. Okay, so again, another skill you should be able to do, which is working with fractions and simplifying it to get a limit that you can deal with. One more. The limit as x goes to negative 1 of 2x cubed plus 3x plus 1 over x squared minus 2x minus 3. What do you think we have to do here? Well, we definitely have to factor these. So let's begin by factoring the top and the bottom, and oh, this is going to be so much fun to factor. So 2x cubed plus 3x plus 1 are constants, should multiply together to get 1, they should add together to get 3. So this looks like it's going to be 2x plus 1 multiplied by x plus 1 when we factor. We can multiply these out to check for sure, so that'd be 2x squared plus 2x plus x, which is 3x, plus 1 times 1, which is 1, so that works. And then, of course, the bottom would be x minus 3, x plus 1. Usually a good trick is to factor the easier one first, which is the bottom one, and then see which one of the factors divides into the top one, because normally you're canceling one of those factors to make the question work. So I could have done x minus 3 and x plus 1 first, and then tried both of these to see which one was part of the numerator. But at this point, well, we see these two nice things cancel there. So this will be the limit as x goes to, this is negative 1 of 2x plus 1 over x minus 3. So we can just plug in negative 1 now. So this will be 2 times negative 1 plus 1 over negative 1 minus 3, which is going to be negative 2 plus 1, which is negative 1 over negative 4, which is just equal to 1/4. So that's solving limits algebraically. All of these tricks and methods will be used for your limits on your exams. So please make sure to practice them. Do as many practice problems as you can. I'm sure you have a textbook for your course. I highly recommend doing every single question, even if they seem easy. Just do every single question. Tons of resources online. And if you have any questions, please leave them in the comments below and I will do my best to answer them.